Howdy, this is John Gerding.
Hi, this is Xiaochen.
And this is going to be homework 10, and this is problem 626. We're going to be finding the transfer function for this circuit, and we're going to begin by reducing the components and creating impedances from them. So we've divided this up into the parallel portion of C1 and R1, and then the series portion of R2 and C2. And so we've got a quick little note up here just to remind us of what the impedances of these components are. And so for the parallel portion of the circuit, we've got the impedances combining here, and that's labeled as Z1 in red. And that ends up being R1 over the quantity of C1 R1S plus 1. And then Z2 in green is just the series component, which is 1 over C2S plus R2. And we've gone ahead and kind of combined those with a common denominator, just to make it easier a little bit further down in the problem. Second, we're going to apply Kirchhoff's laws. So we've got the summation of voltages equaling 0 as we travel around this loop, and we've gone ahead and replaced the components with their equivalent impedances, Z1 and Z2. And we've made a note right here that's important to recognize that the output voltage of V0 is equal to the second impedance Z2 times the current. And that's going to allow us to then simplify the expression that we get from Kirchhoff's loop law all the way down to V sub 0 being equal to the input function, which is V sub s, over this big quantity here, which is Z1 plus Z2 all over Z2. So then from that, we can find the transfer function, which we know is V0 over Vs. And then taking that, we recognize through some algebra that is then equal to Z2 over Z1 plus Z2. And we've gone ahead and rewritten those values that we found from the first step. And so from there, it just becomes a little bit of tedious algebra, but we can get there with initially Z1 plus Z2. We first solve for that and get this big old expression, and then we have to remember that we have to invert that because we're going to be dividing the entire quantity of Z2 over or by that summation, and that we show right here. And then in the end, we get this final expression for the transfer function in this green box right here, which is a big long expression. And you could go ahead and simplify this a little bit further by expanding out these quantities on the top and bottom, but you will get the same expression either way. So that's it for problem 626. Have a good day.